The information that empowers and connects us comes back to our global data centers. Built for a secure, sustainable, and digital world, they make the invisible visible and anything possible. And that's the great thing. Together, we do great things.
Chennai, known as the gateway to South India, is one of the major IT and data center hubs in the country. The Adani Group now plans to build world-class data center infrastructure in the city of Chennai. The Adani Chennai One Data Center is the biggest hyperscale data center in Chennai with a 32 megawatt IT load. It is strategically located in Sipcot IT Park with direct connectivity to the National Highway and other major IT hubs in Chennai. The data center is being built to meet global standards with 7 layers of security, best-in-class power usage effectiveness, redundant fiber connectivity and green energy. The Adani Chennai One shall be equipped to provide one-stop solution for all telecom and IT infrastructure needs of hyperscale customers, including low-latency network connectivity, high-performance computing and other value-added services. Through this data center, the Adani Group aspires to contribute to the local economy while continuing our work towards nation building at large and being steadfast on our philosophy of growth with goodness.
Himanshu, shall we start?
Shiva sir, you can take over.
Thank you. So, good afternoon, ladies and gentlemen. This is our session of today's day 2 of Data Center Summit. We have excellent speakers for this particular session. I'm sure this would be the first session where we will have excellent speakers from the industry. Earlier we had panel discussions, we had speakers sharing their knowledge on immersion cooling and power quality. This is our sorry, there was some problem. Yeah, so we will have 3 presentations. I'm very much sure all 3 will have a justice to have this panel a great success for day 2. These 3 presentations are very exclusive. One is on data centers, how data centers are built with high excellence. Then we have one presentation from Mr. Thompson from Armstrong Fluid Technology. He would talk about data center to optimize the performance with no cost. And the third presentation, which would be very interesting for all of us, to have water conservation, to encourage more and more data center to conserve natural resources, including water. So first of all, it is a real pleasure and privilege for us to introduce industry veteran, Mr. Murari Sinal Saab. Sinal Saab is Senior Group Vice President, Utility Services, Reliance Industries Limited. Sinal Saab has more than 45 years of very rich experience handling one vertical to another from inception. He has been known for his great contribution to the Indian industry. Mr. Sinal joined Reliance Industries Limited in November 1981 and continuing his long-lasting service journey in Reliance Industries till that. Mr. Sinal was founding member of Reliance's first polyester plant at Patal Ganga. After Patal Ganga's plant establishment, Mr. Sinal has worked for all manufacturing sites of Reliance Industries, including petrochemical complex at Hazira, oil refinery at Jamnagar, and all the big projects from RIL. He has wide experience in design, installation of 4 lakh ton of air conditioning system, industrial boiler, water plant, STPs, nitrogen plant, compressed air systems, and all the utility services used in Reliance Industries. Mr. Sinal was instrumental in establishing Reliance Infocom Telenetwork in 2002. Mr. Sinal was head of engineering of Antilla and HN Hospital project. Happy to have you, sir. This is a great pleasure for us to have you for this important session, and we are very much sure there would be a lot of learning coming from your presentation. Over to you, sir.
Hello.
Yes, sir, we are able to hear you.
Yes. Should I start?
Yes, sir, please start and also put your presentation.
Yes, let me start. Good evening to everybody. I am thankful to the entire team of IGBC under leadership of Shri Gurmeet Singh Arora for organizing this program. My special thanks to Mr. Shivraj Dhaka to giving my introduction elaborately to the audience and giving me this opportunity for making this presentation. I myself is Murari Sinal, working as MEP head in Reliance Industries. Myself and my entire team of MEP has played a big role in Reliance Data Center in design, construction, and now in operation. So with this introduction, I just start my presentation.
Sir, please share your presentation.
Today, my presentation topic is that best practices in data center at Reliance. So I will start my presentation. With directive from our founder, Chairman Shri Dhirubhai Ambani. As per him, what is good for India is good for Reliance. As what he has narrated in detail is, our dream must be bigger, our ambitions should be higher, our commitment deeper, and our efforts greater. So this is what the directive we have received from our founder, Chairman Shri Dhirubhai Ambani, and we are working on the same directive. Now next comes the guiding principles from our present Chairman, Shri Dhirubhai Ambani, the son of Dhirubhai Ambani, Shri Mukesh Ambani, where he states that growth shall be achieved keeping in mind that design must be most energy efficient and sustainable. National and natural resources shall be used judiciously. So we at Reliance, we all are working in all our projects, and whatever we are doing, work at Reliance, we are following these two directive and guiding principles. Now, next comes my presentation. Let me first state my presentation agenda. It starts with design standards for data center, IGBC guideline, basic infrastructure required, important design features, and data center PUE, best practices followed in Reliance data centers. So I will be concentrating more on detail of best practices followed in Reliance data centers. Now, now I move to my next slide, that all the data centers are designed based on the guideline given by Telecommunication Infrastructure of Data Centers, that TI 942 for different disciplines, that is electrical, HVAC, NBC, NFPA, all this. Now next comes to the role of IGBC in guideline for green data center. So IGBC has put a very good guideline for design as well as operation of data center, that starting from site selection, planning, energy efficiency, operation and maintenance, water conservation, building material, resources, indoor environment quality, and innovation. Now, at the same time, based on their own assessment and evaluation, the Green Building Councils award the certified silver and gold platinum rating based on their evaluation. At the same time, the IGBC has good coordination with for the certification of data center, and Reliance has also applied for this data center certification, and we are expecting that by next month we will get the certified rating from Green Building Council, and we are expecting that we should get the platinum rating certification. Now at the same time, IGBC is doing very good coordination with government agency, that is the ECBC on energy conservation. One of my colleague, Mr. Prakash Lohia, is part of this committee, and he has prepared the specification as per requirement. Now next, I come to the basic infrastructure of data center. So as per Reliance and guideline given by IGBC and other design parameters, these are the basic building requirement for the data center. And most important is the efficient electrical power system with UPS and standby power system. And utility block and efficient chiller system. At the same time, to take care of atmosphere and hygiene, STP and ETP, they are the necessary component of data center. Now, next, I come to the design features of the data center. So these are the important design features of the data center. And the very important from my point of view is clean and corrosion-free environment, and positive pressure shall be maintained inside the server hall to avoid any contamination or any disturbance. At the same time, now I move in my next slide on electrical system for data center, which plays a very big and important role in the data center. So these are the basic components of the electrical system and especially the UPS with power factor as unity shall be designed and installed in the data center. That is a almost must requirement. Now we come to the data center efficiency. There are three ways to define the data center efficiency. Out of these three ways, the power usage efficiency, that is the PUE, is most common term used for data center efficiency. And here in this slide, I am specifying the power distribution for the data center as an example. In this, I have shown that 66% is IT power, 17% is cooling power, which includes the refrigeration chiller, air handling unit, and heat removal system of the server and racks. Then 13% comes as ancillary power, in which electrical, whatever that losses are there, or the system power requirement in starting from transformer to UPS and all that. And 4% is the lighting load. Now this 4% lighting load can be very well saved by generally the data centers are unoccupied and occupancy is not required for all the time. So the automatic switch can be provided to put off the lighting system when it is unoccupied. So this is the elaboration on power breakup in any PUE calculation. Now, as per my thinking and our design, that these are the 5 very important factors for data center efficiency. That is the atmospheric location. It affects very much if it is located, data center is located in hot and humid atmosphere, the loading will be more, the power consumption will be more. At the same time, if it is located in cold area, it will be beneficial. And similarly, the data center building should be extremely thermal resistant, thermal and moisture resistant. Third role comes the heat removal system, that is the cold alley and hot alley, and the next comes the cooling media temperature. Say earlier when we started designing of data center way back 15 years back, we used to use the very low chill water temperature, but now we are using higher temperature chill water. The efficiency of electrical and mechanical system selected for the data center plays a very big role in data center efficiency. Now we come to the next requirement, that is the heat removal system from the servers or the server racks. So different server manufacturer or rack manufacturer, they give different design for data center heat removal system. In our experience and as per our use, we have found that as marked that first slide, most right method, that is the cold alley and hot alley, is the most right design for data center heat removal system. Now, let me come to the data centers at Reliance. So we have right now total 5 data centers under operation. 2 are located in Bombay. One is located in our Maharashtra. 2 are located in our Jamnagar refinery site. So, and 4 more data centers are upcoming. Data centers, one additional data center at our Maharashtra, that other side, and one at Bangalore, one at Chennai, and one at Calcutta. So these additional 4 are coming up, and our operating PUE value, that is the PUE, the efficiency is ranging between 1.3 to 1.7, and our continuous effort is on to reduce it to further. Now let me talk of the special design and operating features of RIL design data centers. So I am proud to say that all these data centers are designed based on the guideline given by our chairman, design codes and standard given by different agencies, and IGBC guidelines given for the green data center. Using most efficient water-cooled chiller, using most efficient airflow system, that is the cold LE and hot LE, using this chemical filter, thermal storage, pre-cooling coil, and rainwater harvesting. Now I will elaborate on these 4 points. Say earlier, as I said, that we used to use 712 degree centigrade chill water system for our data centers, which we modified and improved to 20 and 27 degree chill water system, which has reduced our power consumption from 0.6 to 0.3 kilowatt per TR. Ladies and gentlemen, here I will like to elaborate and say a very important information to all of you, that first time when we floated the inquiry in the market for giving a water-cooled chiller for 20 and 27 degrees chill water temperatures, nobody was ready to give any quotation, and they were surprised that how you can call this higher temperature as chill water. But we insisted for the same, and subsequently now all the chiller manufacturers are ready to supply this requirement to us. So this I explained that how we have improved the data center efficiency by using higher chill water temperature chillers. Now next important factor comes, as I mentioned earlier, that cold LE and hot LE. So we have designed and installed this cold LE and hot LE system, in which cold air is supplied from the bottom of the server hall floor and hot air is collected from the top, and this is how we are achieving very best results. Now next comes the chemical filtration. You see, as I mentioned, that it depends upon the location and the vicinity of the area, that how contaminated are your atmospheric air is. Unfortunately, for different requirement, two of our data centers are located at Jamnagar, near to the refinery complex, where we are getting atmosphere contaminated air, and because of that, we are using chemical filtration for the entry of fresh air in our data centers. Now next comes the thermal storage. So this thermal storage system, designed by my own internal team and fabricated and installed by our own team, has given a big help in improving the reliability of our data centers in all the location. Say, when this DG power, in case of power failure, it takes some time to get DG started and come under loading, and then subsequently chiller load comes on that. So it takes some time, and data center, that cooling system get disturbed. So with the help of this thermal storage system, we very well avoided this system, this failure, and we have improved the reliability like anything with this help. Next comes the water side economizer at data center. Now, as I mentioned, that based on the data center location, it depends. So we found out and we observed that at Jamnagar, location like Jamnagar, 70% of the time that cooling water outlet temperature from the cooling tower is either 27 or even less than that. So we have installed that economizer in data center cooling coil, and we are getting advantage of this low temperature cooling water temperature in that system. Next comes the rainwater harvesting. So all the data centers rooftop, we have provided the arrangement to collect the rainwater, and this we are using this collected rainwater for our cooling water system, makeup water for the cooling tower. And thus, during the monsoon, we are saving that additional water requirement for makeup in the data center. So, ladies and gentlemen, I have made my presentation and elaborate on the special features of the data center in terms of energy conservation and design on Reliance data centers. And I thank you very much to everybody for patience listening and giving me this chance to make this presentation. Thank you.
Sir, thank you very much. It is always pleasure to hear and to have your more and more inputs on our data center design. Whenever we visit your data centers, we always get some new ideas how Reliance is putting great efforts in reducing the PUE. And we have seen your data centers and the kind of logic, kind of innovations you put in data centers of Reliance. I think it's a great work, and we really appreciate your innovations in data center. Some of the new things that we witnessed last year during visit of your data center along with Dell-Sarter, that was to have some customized arrangement for the racks, so that there would be no leakage of air. That is like wonderful things, and it is always inspiring to work with Reliance, especially with data center team. So thank you very much for your very detailed presentation. And now we would like to have another presentation. We have Mr. Thompson. Mr. Thompson serves as Director Global Building System Solutions Group at Armstrong Fluid Technology. He leads key functions such as new product development strategies, IP development, and strategic business promotions at Armstrong Fluid Technology. Prior to joining Armstrong, Peter's leadership experience spanned a range of industries, including commercial building, energy conservation, rail, and power generation. So he has very wide experience in different domains with responsibilities for a solution portfolio that includes plant automation solutions, packaged plant rooms, fire suppression systems, and building optimization services. In his 20 years career with Armstrong, Peter has focused on developing solutions to provide improved building performance, energy efficiency, and sustainability. In today's topic, he has mentioned like data centers should be optimized with no further adding of costing or investment in that. So I think that would be very interesting for everyone to understand and explore how a data center can be optimized with very much reduced cost, or there is no cost in adding the features. So over to you, Peter, and we are very happy and it's a real pleasure for us to have you. Thank you. Over to you.
Thank you. And I'd like to start by thanking the organizers of the event for allowing us to present. Can you see my presentation?
Yes, we are not able to see right away. Please try to share it. Yes, it is getting uploaded. Please put this on full mode.
There.
Right.
Terrific. Well, thank you and welcome everyone. Good afternoon. My presentation focuses on high reliability, high resilience data center design. And it's really been a challenge for the industry because as we approach those designs, we're challenged in creating automation sequences that give both reliability and resilience. And with all the complexity of N+1 and 2N and 5 nines performance, often it becomes very difficult to implement optimization strategies because maybe we have dual controllers, we have dual communication lines, we have dual control signals, dual devices on parallel paths and parallel pipe runs. So that's really where I'm focusing today. And what we've done at Armstrong is we've developed a methodology to overcome that barrier, where we can have both high resilience with data center design and layout, and also get very good PUEs without sacrificing the performance just because we went to a high reliability data center design, that we can still achieve those great PUEs. Just a quick background on who Armstrong Fluid Technology is. We're a global designer, manufacturer, and life cycle service provider for heat transfer and fluid flow solutions. Driven by learning and innovation, we've been in the data center community for over 20 years. We manufacture off-site chiller plants, cooling systems, componentry like pumps and heat exchangers, and also automation and optimization platforms. Now, why we've been so successful in the data center community, we help with rapid deployments of data centers, reducing the schedule for the full project site by up to 6 weeks. We can reduce peak power by approximately 6%. So this is a connected power for an equivalent data center. And we help to reduce OpEx through improved PUE of up to 18%. We've done that for the total data center. And we also try to improve the utilization of the assets. And we do this all with transparency, with a digital methodology, a feed-forward control technology that enables us to give performance commitments on the data centers that we deploy. So I'm referring to an industry norm called Tier 3 versus Tier 4. And really, just as a reference point, let's say, on what we mean by a high resilience, a high reliability data center, where with tier 3, we're trying to achieve 5 nines reliability, 99.999% uptime, and the ability to service or remove any component from its duty and still have that data center perform. And the other option traditionally thought of to get really high reliability is to have a 2N data center, basically a duplicate cooling plant to continue with cooling. If there's problem with cooling plant A, you employ cooling plant B to pick up and take over. But there's some real advantages to going with a tier 3 design, which is often thought as N+1, versus tier 4, which is thought of as a 2N design. First, there's the attractiveness of a much lower first cost, less infrastructure, so less embedded carbon footprint with that approach. So when we think about our 3 scopes of carbon, this is really helping to reduce that embedded scope. There's less maintenance and service costs to a tier 3. And also the productivity of the tier 3 assets are far better than those of a tier 4, where the second data center is really only called upon if there is a failure. But there are some challenges. You know, it's very easy to have 2 chiller plants, traditional, and optimize them because they don't have to have shared control, shared instrumentation, going back to the control system. It's a very simple story to optimize. When you get into the N+1 topology of a data center, and you've got duplicate pipe runs with duplicate valving, duplicate instrumentation, and you need the ability to have hot swap on your controller, it becomes far more complex to optimize. So for that reason, most of these high resilience data centers are primarily driven in their automation sequences around resilience, and there's very little room for optimization. So what Armstrong thought was, we need to clear the table, we need to change that. What we'd like to do is come up with a topology for the control system where it is adaptive and easy to install optimization and doesn't present that type of barrier. And we did come up with a solution. We've branded it Evercool, and it's a factory direct solution that can be installed and adapted to pretty much any data center design. But here I'm going to focus on the dual ring tier 3 type topology with the dual pipe runs, dual instrumentation, and dual valving, just to give you an idea how we've taken that philosophy and we've actually embedded it into our controller. So our automation platform, basically we have a master PLC and we have a hot standby PLC with a switch, where the standby PLC is mirroring the control activities of the active master as it's operating. So it's 100% mirrored, and it can switch over and take control in less than 300 milliseconds. But that's a traditional thing. That's nothing new. What we have done to add for resilience so that we could have a common controller that's being mirrored is we've created a dual communication path, serial communication to all the devices, the instrumentation, the controlled equipment, anything in those pipe runs, and we have an I/O point for set A and an I/O point for set B. If we had a communications break here between device A1 and A2, where we daisy chain serial communication between the devices, we can communicate to those devices through the opposite part of that ring. So we've created a ring topology within our controller that allows us to have 2 communication paths, just like the ring topology gives you 2 parallel pipe networks for your primary pumping and your secondary pumping and your distribution lines. We've done that with the communications network to enable us to handle or manage any break. Now we're always communicating from either the master or the hot standby with the same methodology and identification of those components and instrumentation out in the field, and we're not relying on two networks of communication, but one single network topology, whether there's a break or not. And this fundamental shift in our design allows us to easily implement an automation scheme that would be on a traditional normal N+1 plant without the duplicate valving and pipe runs. So now we've enabled a platform where we can bring in that bump-free transfer, that high resilience, and embed a new form of automation. So this is really also a big cost savings because we've done away with the need for complete duplication of our controllers, which is typically the approach taken for very high resilience. And we've embedded that into one Evercool platform. This, because it's a factory supplied solution, it will help save with design time. It'll help save with the site work. It'll reduce the data center cooling costs because we can embed optimization with a traditional approach, around 40% energy savings, a dramatic improvement in PUE. And how we do that is with digital twins. Our optimization that we provide is based around machine learning technology, and it's been branded, the product is OptiPoint. And very simply what we do to create our digital twin is we'll create a dimensional space, and simply I've shown it here for a pump where we have flow on the x-axis and the head pressure of the pump on the y-axis, and we capture at every operating point the head and the flow and the corresponding power and speed. This is how we create our digital twins. For a chiller, it's approximately an 8-dimensional space. For a cooling tower, it's a 5-dimensional space. But what this enables us to do is identify the power associated with a certain operating situation or characteristic. So we now know for a given lift, perhaps on a chiller, and delta T across the condenser and evaporator, we can predict the performance of the chiller, and we can come up with an operating scenario through machine learning to optimize or minimize the power production for a stated load requirement and atmospheric condition. So by collecting all that data in real time, we're not relying on theoretical models. We're actually getting the real data from the site as it's installed. It takes about 2 months to do its learning cycle. Once it's achieved the learning cycle, it can go to fully optimized control with digital twins. We've implemented this approach on a number of sites with great rewards in PUE and energy efficiency, where we've proven out energy savings on the order of 25 to 30%. Another terrific benefit of this is if there is a problem with any piece of equipment, the digital twin will predict performance different than it observes. And what that tells us is that there's an issue with that piece of equipment. Perhaps the power draw has gone down for a previously observed fan speed under a certain weather and load condition. That would suggest to us that there's blockage of the airflow on the cooling tower. So embedded within this automation system is predictive capability to identify and recommend remedies to scenarios that can typically occur in a chilled water plant so that the maintenance personnel can go out there and address them before they begin to sacrifice too much of the performance in the PUE of the plant. And this is probably one of the biggest challenges with operating a high performance chiller plant, is avoiding what we refer to as drift. Because things happen slowly over time, it's invisible to the human eye or human operator to know that I could be getting better performance from my cooling tower if I did a quick maintenance call on it. And knowing that will help them maintain the performance and stay on this lower line of PUE for the chiller plant. So in closing, this new platform from Evercool, we're quite excited about it. We've had 2 deployments so far with great success, and we're looking forward to many more project opportunities to help improve PUE and at the same time deliver very high resilience. So again, thank you to the organizers, and I hope I have the time to come and visit you all sometime soon. I am actually calling in from Toronto on a rainy day here, and I look forward to my next travel to India. Thank you.
Yeah, Peter, thank you very much. Absolutely, it is a great presentation for all the audience to explore and understand the optimization in data centers. Will you be available some more time, or should I have some questions here? You are muted, please unmute.
Yes, absolutely.
Yeah, so are you here for some more time?
Yes, for the next hour, I'll be available. Yes.
All right, thank you. So we have next presentation, which is on water conservation, and you all understand India is in water scarcity, and mostly all tier 1, 2, 3, wherever we go, we will find a huge water shortage, and all the municipal corporation all across the country, there would be good gap in demand and supply. So we have an expert called Michael Betty. Michael is leading global data center design engineering specialized in Nalco Water and Ecolab company. As part of the Global Data Center Solutions Group, he is responsible for advising and supporting data center engineers, owners, operators regarding water and energy related decisions. This includes site selection, water assessment, cooling system design, water consumption treatment, water reclaim, water pre-treatment equipment design, water related CapEx, OpEx, and newer sustainable water strategies and technologies. I think there are many things to discuss about water conservation. Michael has managed multiple data center design build projects, from new builds to live data center upgrades, and these are from small data center to multi-million dollar in values. He has acquired top secret DoD clearance. I don't know what is called DoD clearance. He will explain during his presentation, and has performed data center energy and reliability audits for the US government and private industry. He also has vast experience in doing forensic analysis for data center equipment failures and implementing solutions for remediations. I think it's a real pleasure and honor for us to have Michael Petty, and we have shared this information to several data centers. Those are very closely working with us to explore and understand the possibility of water conservation in data center. We know some of the data center from Chennai, they found huge scarcity because municipal corporation were not able to supply the water to data centers, and they were either shutting down the data center, which is not possible for even microsecond. So it's a very scarce situation for everyone to understand. So I think it's a great presentation, and we are really looking forward to his presentation. Over to you, Michael.
Thank you very much, Dr. Shivraj. It's really an honor to be here. I'm going to go ahead and share my screen. By the way, as I'm doing this, top secret DoD, that basically means top secret with the Department of Defense in the United States.
Okay.
Just so you know there. Okay, can you see my presentation okay?
Yes, it is.
Thank you very much. So at first, I'd really like to thank the CII and the IGBC for the honor of speaking with you today. It really is an honor to speak with so many esteemed members of the data center community in India. I've watched quite a few presentations, and I've been very impressed at the expertise and knowledge of the people in the engineering community in the data center community in India. In this session, you're going to learn about some innovations and tools that are helping sustainability-minded data centers uncover water-saving opportunities and build action plans for smart water management. So it's certainly very common knowledge that India is a water-stressed country. It's obvious to see this in this map where the data centers, most of them are being built in India in the city locations. And it's important that the data centers pursue excellent practices regarding the consumption of water. there's going to be tremendous growth in the data center industry in India. And so this needs to be recognized, this needs to be seen and planned for. And I've really been impressed at the plans and things that have been put in place so far. The 24/7 operation of data centers and the need for business continuity creates the need for a proper assessment of the risk regarding water so that there's not an impact in business continuity. So a very key question is, how do we evaluate the risks of water stress in a local watershed and their potential impact on data center operations? So Ecolab has developed an online tool. It's a free tool, and we've done this in conjunction with Microsoft and TrueCost. TrueCost is the risk and analysis arm of Standard & Poor's. We created this tool. It's publicly available. It's called the Water Risk Monetizer, and it's used to evaluate the risks regarding water. There's two primary aspects of risk associated with water: water availability and water quality. The first has to do with assessing whether there's going to be enough water for future operations. Will that water be available when data centers need it in the future? The second aspect of evaluating the risk has to do with the quality of the water supply. In the event of drought or other negative conditions environmentally, will the water quality change? Because water quality and water chemistry has a definite impact on what can be used in the data center and how concentrated it can be cycled up in the applications. So by using this tool, data centers can evaluate local water supplies and resources and alternate resources, and then apply best practices for the conservation, reuse, and recycling of water. So the very good news is that the CII, IGBC, and partnered with LBNL have been planning strategies to help minimize the risks associated with data center water consumption. The ECBC 2017 guides for data centers were developed to help implement sustainable water strategies. So using strategies of rainwater harvesting, sub-metering to monitor where water is being used, efficient plumbing fixtures, and water reuse and recycle, these are all aspects that are going to help minimize current and future risks regarding water availability. In the chart, you're going to notice the items in red. These are requirements. They are mandatory for all three levels of the ECBC guidelines. Data center rating credits can also be obtained for the additional items of efficient plumbing fixtures and water reuse and recycle. And so these credits would apply to the data center rating. And so as the data centers look to be more efficient and would choose to pursue super ECBC level of status, it's quite a challenge in India, and to target that PUE below 1.2. But putting these things together and setting the guidelines and strategies to do that and encourage data centers to do that, I believe the ECBC is doing an excellent job in serving the communities in India and the residents of India. So at Nalco, we developed another tool we call Smart Water Navigator. And Smart Water Navigator is a tool that helps support businesses with conserving water in their operations. The tool uses a proven 4-step method to enhance business resilience at all levels of an organization through smart water management. So just walking through the 4 steps here. Step number 1 is identifying the water-related business risks, assessing those and quantifying those risks in financial terms. Step number 2 is targeting and setting water targets for managing the water use risk. Where are the areas of greater risk? Where are the areas of greater future risk? And then deciding and planning solutions in how to minimize that with a number of solutions, and we'll talk about them a little further in the presentation. Step number 3 is implementing practical projects to advance corporate water targets and utilizing specific guides for the data center industry. And the last step in this, and using this Smart Water Navigator tool, is tracking the performance over time and revisiting the action plan to continue to improve and handling and using water and conserving water, which will benefit the greater community of India. Some other nice parts of this tool are the tool can be used in local facilities for local engineers and data center operators working on projects. But the tool also provides a holistic view of the entire operation of a company in multiple sites and facilities. So it enables corporate leaders to have dashboards to track and monitor the water usage and the water improvements that are being done within the company. So it's important to have that kind of visibility. It's one thing to manage and operate 2, 3, 5 data centers, but when that grows, and India is certainly going to grow in the number of data centers, when that grows to 40, 50, 100, 150 data centers, it becomes much more complicated to follow and to track corporately. So setting the strategy in place early is helpful so that as you grow, you're able to manage that, track it, and make wise and intelligent decisions in improving water conservation. So in this next slide, basically with data centers, there are multiple aspects of water use in the data center. And so it's important to develop a plan in this journey to water conservation, to look at where the water is being used, how it's being used, and where any water is being discharged or wasted. And could that water be reused back in the facility? So within Nalco, we have developed some digital platforms we call Ecolab 3D. And with Ecolab 3D, we monitor and track the usage of water throughout a customer site. We help them to track that. And if there's aspects where something is going wrong, where there's been an equipment failure or a problem, that alarms and things can be sent so that people are made aware and can track down that problem and deal with it before it becomes a major problem. We call this tool water flow intelligence. It helps to quantify and understand the water usage across all sites, not just a single site. And it's very important to facilitate the benchmarking to begin. Where are the data centers operating now? And then bring that into accordance with whatever objectives that the company has for water use long-term. So I think it's important to discuss a key performance indicator in the monitoring of water consumption. WUE, water usage effectiveness, has been a KPI in data center water consumption for a number of years. And the calculation has been very simple. It's simply the ratio of the water consumed in the data center divided by the IT equipment energy consumed, providing a number in liters per kilowatt hour. There's a more holistic approach to this, which I think is important, and it relates directly to the efforts of the data center industry to utilize renewable sources of energy. The chart on the right here, you'll see, shows how much water is consumed based upon the type of utility power generation source that's being used. And when you look at these charts, it's very easy to see that using wind and solar and photovoltaic renewable energy sources use much less water in the production of energy. So WUE source is a helpful tool. It's a helpful parameter to track and monitor how much water is actually being used, not just in the water consumption at the data center locally, but also what water is being used at the source. This helps to drive utilities toward greater use of renewable energy sources and improving the sustainability overall for a country. I'd like to share a couple success stories that we've had at Nalco Water in supporting clients regarding water conservation and assessing water risk. So in this particular case study, Microsoft used the Water Risk Monetizer to help make informed decisions about water management at its data center in San Antonio, Texas. This location in Texas in the United States is a very water-stressed area. It's located within the Leon Creek watershed, so it's extremely water-stressed. And so it was very important in this project to look at the risk associated with water. After analyzing that risk, it revealed that the risk-adjusted value of Microsoft's water use at this data center was more than 11 times greater than the current water bill presented by the San Antonio water system. So there was a lot of risk associated with the cost and availability of water in the future. And based on this information, then numbers were put together for a business case for Microsoft to install Nalco Water technology and enable the plant to reliably use recycled water instead of potable water. And this ended up saving Microsoft more than $140,000 per year in water costs and avoided using almost 60 million gallons per year of potable water. So finding and then deciding how to reuse alternative water sources, industrial, sewage recycle, these kind of things. These are things that data center companies need to think about. And especially in India, these are important projects and things to consider and to evaluate. So here's another aspect of a customer that Nalco Water has helped on their journey to becoming water smart. Digital Realty is a global provider of co-location services and solutions. And Digital Realty was on a mission to improve its water strategy, to minimize overall water use, to ensure reliable performance, and protect its operations from water-related risk. So their motivation behind developing and executing on a global water strategy was driven based on the critical role that water plays in their operations for many of their data centers across the globe, and always ensuring that it's enabling them to operate efficiently and maintain critical uptime. This was further driven by their awareness of water scarcity, their understanding of the need to look at the total hydro footprint, potential quality-related changes, and their commitment to protect the local watersheds where they operate. So Digital Realty partnered with Nalco Water to evaluate the current state of water consumption across their enterprise. The Water Risk Monetizer was used to evaluate water risk at each location and prioritize areas of greatest need. The Smart Water Navigator allowed them to assess how their individual facilities were performing compared to industry-leading water management practices. So these tools placed each facility on a water maturity curve and generated a location-specific guide with practical action steps to build water smart practices and allow them to prioritize their list of water hotspots throughout all of their facilities. So now they have started on the next step of the journey, which is to improve water use practices at the local levels, evaluating projects, deciding which ones make sense to do first, and prioritizing them. They're also using the water flow intelligence platform of Ecolab 3D and monitoring and tracking the water and then developing projects to improve the water usage practices so that there is a benchmark to start and then they can evaluate improvement over the long term. So all of these efforts are basically to help customers in the data center industry walk along this water maturity curve to being where there are untapped resources to helping them to be water smart in the operation of their data centers. Here's a summary of a number of projects that Nalco and Ecolab are doing in India right now. We are very active in the nation of India. As you can see in the listing of these projects, well over 85 projects in water pretreatment. When it comes to sewage treatment and effluent treatment, we have right now ongoing over 120 projects in India, helping customers to reuse these water sources, to treat them, to deal with them. And we have many reduce, reuse, recycle projects as well. We also will work with customers in the engineering and design and build support of water projects. That could be RO, ultrafiltration, a whole number of different solutions that could be implemented. And we are happy to support customers in India. One of our strongest areas of operation in India is managed operations. We have well over 150 locations where we manage the water room or water operations for customers in India. This is an area in much demand. Nalco provides a lot of labor resources and especially the technical and expertise in the areas of water treatment and water reuse and recycle, and helping customers to make wise decisions on what to do with their water resources. So we do quite a bit of this work in India. And then below this, I've listed, we have quite a few projects going on right now within the data center segment. We're 2 greenfield projects involved in the design stage and helping them to get started in the planning and what to do with the best choices of water use and consumption. And then we are also involved in 9 brownfield projects and helping these customers to do better projects and improving water conservation and recycle and reuse as well. So that being shared, I'd like to share a side note that I think would be helpful for the data center community in India. And that has to do with data center education. So when I was invited to speak, I was very pleasantly surprised to find that the ECBC and the CII and the IGBC were working with the Lawrence Berkeley National Laboratory to develop guidelines for energy efficient data centers. I'm very familiar with LBNL and what the work that they have done in the United States. 5 years ago, I took a course that they had created in conjunction with the Department of Energy and have partners who administer the course and certification. We refer to it as DCEP, but that stands for Data Center Energy Practitioner. And there's a pass, an exam, and a certification associated with this. So I think that this is very helpful. There are many very educated and knowledgeable experts involved in the group advisory board on ECBC. It's also important, and I'm sure they all understand, to educate the future generations that eventually we'll hand off the baton to future generations of people. And we want them to also do well in sustainability projects and working water conservation projects and being good stewards of the environment. And so it takes training and understanding of the concepts and that are involved with data centers. Data centers have come a long way. 20 years ago, there were not a whole lot of different ways of cooling a data center. There were just a few. And if you look at this list right here, there are many ways to cool a data center now. And many of them are extremely energy efficient. So you will need educated people who understand the concepts of PUE and also the limitations of PUE. You have a few presenters talking about immersion cooling and liquid cooling at the chip as well. And one of the benefits of that type of cooling is that it can eliminate the fans in servers. This is something that a lot of companies are looking at in the United States. A side aspect of that is it does not reduce PUE. Because the fan energy in a server is included in the IT calculation in the PUE formula. So it's important to understand these nuances and differences for data center design engineers, for data center operators, for mechanical, electrical, plumbing, professional engineers who are designing data centers, and also for the people who are working in operations of data centers. There are a number of data centers where it makes sense to do hybrid cooling, where there may be one primary type of cooling, but also a specialized type of cooling at the chip or immersion cooling as well. So there are many different avenues in how to design and build centers. As you can see, lots of very energy efficient cooling methods. And there needs to be decisions made on what would a hyperscale type data center cooling look like? What would a co-location data center cooling look like? And what would enterprise data center cooling look like? Because they each have different needs. So again, I want to encourage the education of the community and the engineering community. I would encourage you to talk to Dale Sorter and LBNL regarding opportunities improving this. Continuing to go along regarding data center education, Nalco Water, we do education for engineers. We have Nalco Water University. We do engineering webinars for data center engineers, as well as lunch and learn sessions. And I was also very pleased to see that you have representatives from EPI and Uptime Institute in the advisory committees, as these companies have very important training and education certifications that will help to bring forward new engineers in the next generations to learn and to be able to bring sustainability offerings. I'd like to close this with an anecdote. I live about 2 hours away from Northern Virginia. And Northern Virginia is also called Data Center Alley. Data Center Alley is the single largest concentration of data centers in the entire globe. I talked to a good friend recently who does a lot of work in real estate in the area, and his estimate is that there are about 3 gigawatts of data center capacity in that greater region. So 3,000 megawatts. It's a tremendous amount of power, tremendous amount of water. And what I found has been key to their success is that they have been able to organize local governments, local utilities like power utilities and local water utilities to work together to plan how to do data centers well and to do it sustainably. And so it takes a cooperation of quite a few aspects of the community to do this well. And that's why I think the more that you do data center education, and whatever that looks like for India, I want to encourage you, because you need to educate people in the power utilities and the water utilities and other aspects of the community so that they can understand the informed and wise decisions that you're making when it comes to designing and building data centers. So I hope this information has been helpful for you. I really want to thank you for the opportunity. Thank you, CII. Thank you, IGBC, for the opportunity to share today. It really has been an honor, and look forward to working with you more in the future. Thank you.
So great presentation, Michael.
Thank you very much.
We are really happy that you are having a lot of projects in India.
Thank you. Yeah, I'm very grateful. Yeah, sir.
Yeah, so there are a lot of questions for both you as well as Peter, and we have received questions for Reliance as well. But the biggest thing is to associate with IGBC on water conservation front. We are doing a lot of work, but this is related to data center only. So we don't want to confuse you so much things with that. So actually we have developed the net zero water certification. We are working with a couple of projects, some 7 or 8 projects. They are having great difficulties in having the total water balance for the project. You know, energy will have many opportunities to generate, to harvest, to do many more things with that, but it is not easy with water. And definitely we don't have any opportunity to generate the water like renewable energy sources. So we will be very happy to connect you with some of the landmark projects in India. I don't think you are connected with them because they are in conversation with us. Okay, few are data center, but some are commercial buildings. So I have already noticed you are also working with commercial buildings, including residential. So some projects are there. They are trying to achieve the net zero water goal. The total water should be completely replaced with the alternate water. So we will be very happy to connect with you, and I believe there would be many more opportunities to work together on this front.
Thank you. Yeah, I agree, and I think there are some things, because you are going on a path of such tremendous growth in the data center industry. I think there are some things that we could help you in learning to grow in Northern Virginia and in Southern California, for example. There is a large-scale effort to use reclaimed water, so industrial water, and reuse it in data centers. And again, it takes the communities, it takes the different utilities and people to work together in the planning. And one of the things that I think is very important for data centers is they don't want to be seen as competing with local residents for water resources. Nobody wants to be in that position. And so the opportunity and ability to use non-potable water sources, to use non-potable water, recycle and reclaim, that could not be good enough for drinking anyhow, but would certainly be fine for cooling a data center in the right application. It's really important to look at and evaluate those projects because it definitely shows that the data center industry is working diligently on sustainability projects and cares about the greater community.
Right. So I have one question for you. What is the business model you follow in having this implementation in either data center or commercial buildings?
From a business standpoint, it really starts at the executive level. It needs to start at the top. And so, for example, with Digital Realty, our corporate account manager working with Digital Realty met with the executive team and began the discussions and helped them to define what is our water strategy? What are our global objectives, for example, for Digital Realty when it comes to water? and then help basically hold their hand and walk them through that process to make wise and informed decisions. We don't expect CEOs and vice presidents to be experts in water chemistry and water technology. That's what we do. But we also know that they need assistance, that they need help. And then once we present them with all of the information regarding the different aspects and recommend solutions, then they can make informed decisions. So from a business model, it really needs to start at the top and be collaborating within the organization to come up with a plan and discuss that and actually come up with, and then once you just define the objectives for the organization regarding water, then you can take the next step, which is, okay, how are we tracking what we're using right now and at least benchmarking? So that's the next key step. And once you benchmark and you look at that, usually the hotspots come out pretty quickly and you can identify where key projects would be necessary to improve those numbers.
Great. So I think we will have more discussion offline to explore all the possibilities and to offer benefits to several clients in India. Yeah, coming to Peter, he made excellent presentation, and his title itself says no added cost to the project. So Peter, what is your thought process for having the data center optimization? You have especially mentioned there would be no added cost in that. So how do you optimize the whole system? Do you have some specialized tool coming from the Armstrong, or do you have some other tools which are utilized to optimize the whole system there?
Well, the approach that we take with the new topology in our controller actually reduces the number of control devices required on site. And because it is a factory-built device, it brings a lot of savings to the project. So it's the net cost of the project where there's no extra cost, and we can integrate that optimization right on the platform from the factory. So there isn't a big process independent of commissioning to try and commission a second optimization platform. It's already embedded in the factory solution. And that's really how we bring optimization to the market without any extra cost.
Great. So because automation optimization would require a lot of field data or the actual data collected at site. So in case the project is not having sufficient control measures, sensors, or having some automation, if it is not up to the mark, what kind of strategies you put there?
Well, that's always a challenge, because to really do optimization, you want to know how the plant is performing. You need to know that it's achieving its objectives. What is your baseline? What is your goal in terms of PUE improvement? And there is a requirement for a basic amount of instrumentation. Flow is the most important and often overlooked element of knowing your heat transfer and the performance of your system to provide that heat transfer. So our technology with our intelligent pumps, they're able to provide flow data on any of the circuits where fluid is being pumped. So whether it's a cooling tower or closed evaporative circuit, if it's the chilled water circuit, if it's a distribution or tertiary circuit. So full heat balances can be done to assess the performance of each circuit. So that's one of the building blocks. And it certainly saves a lot of money because we don't have to install flow meters on all three of those circuits. A flow meter, you need 15 pipe diameters of straight pipe to get an accurate reading. So we eliminate all those costs. And that really takes away a lot of the traditionally thought of costs to get instrumentation installed. So those are the methodologies that we employ to get really high performance with no extra cost.
Great. So we are aware Armstrong Fluid Technology has a good presence in India. Have you implemented optimization of this kind in any of the data center in India?
We're just in our first deployment in India, and we should have some results next week. So I can't give away the name right now. We'll have to wait until they want to do a press release. So I need to hold back on the name, but hopefully within 2 or 3 weeks, we can have some exciting first reveals of the results.
Great. So I think IGBC is well connected, deeply associated with like almost all the data center companies in India. And we will have offline chat to connect with some more data centers, because this is a realistic problem everywhere. Because we can optimize a small system, but it's so difficult to optimize the complete data center to get the best possible savings. And there your statement makes more sense, because you don't need to invest anything. It will give you back so quickly, so that investment will be paid back immediately. So what is your business model? Do you have investment in that, or what kind of things will be implemented in data centers to have the right optimization?
So really, you need to start out from the design phase, and we work very closely with design consultancies to meet the requirements of the customer project needs and integrate the technology properly up front. And then we have a lot of field service partners. We also have our own field service staff to help with the construction, to ensure everything's constructed properly and do check-ins during the construction process, and then the commissioning. And this is all traditional approach that's required on a data center. The more important for optimization is the ongoing observation and maintenance to ensure that you don't sacrifice performance because you have a clogged strainer or any simple thing like that. So we have a digital technology that the customer will get alerts directly through their own remote terminal units, their own platform, whichever unit they're using, or through Armstrong's platform, or directly onto their mobile phone. So that's really where the world of optimization needs to go, is protect that investment. And we do that electronically with the condition-based maintenance approach.
Great. So one last question for you. A data center will gradually loaded from 10% to 30 to 80% in 3-4 years, 5 years. Okay. So how your control measures will affect this?
I'm so glad that someone mentioned that. Most people think that data centers go online and all of a sudden they're at 95% load. And that's that part load operating region. Sometimes the light loads are too light for the equipment to come into their sweet spot, which is a shame. So we always recommend to designers to have incremental units. Don't put 2 large cooling units in. Try to put in 4 slightly smaller cooling units. So during that progression of the load, you do have sweet spots for equipment, that you don't consume extra water, that your tertiary loads like pumping energy and fan energy can be a fraction of the actual cooling load. We've seen sites start up with 5% load, and the chiller plant load is more than the actual cooling load. So very important to think that through, very important that you're efficient through that whole life cycle of the data center, not just the end day.
Great. So we are running slightly late. So we are having some data center where data center owner itself is very highly committed to have more and more savings in that. And already we have identified some of the areas where saving would be definitely there to tap. So I think we will get connected after this conference, especially like next week or so, when you are available, your team is available, and then we'll further discuss it, because both the presentation, especially yours as well as the Michael, they are having a lot of business sense with every data center owners, and it can be further explored to like many other building typologies. So thank you very much. Very interesting presentation, and I think it will help us to have more and more tangible service. We have Murari Snell sir. Sir, are you there? Okay, I think we had one question for him, like whenever they put data centers, what kind of innovations they put so that it will achieve the lowest PUE. I think that was the question. We will get connected with him offline to answer this query to one of the participants. So thanks to all attendees, all the speakers, and those are having this particular session virtually this year. Hopefully, once our lockdown is over, we will try to have physical meetings. There were very interesting presentation about water conservation in data centers. and how to have the better optimization for data center, because that is the thing I think would need more and more deliberations. And it is the only area which is lacking in many data centers. Especially every data center will have sophisticated PMS, EMS, SCADA, and many more automated tools there to rigorously work and put the data back to the source. But many a time this data is being stored, but very few times it will be digged out to get some decision making in that. So thank you everyone for having such a wonderful session this evening. And I request all of you to please try to visit the exhibition. There would be many more interesting, and this time you can have live chat with them. It is a kind of real time experience to have this knowledge exchange with all the service providers. So thank you once again, and look forward to the day 3, where we have very interesting presentations, and there would be keynote session by Adani to understand and explore the data centers at hyperscale level also. Then we have one more session, that is sustainability in hyperscale data centers. Earlier we talked about half megawatt to 1 megawatt. Then in recent parts we were having talks about like 5 megawatt, but today we talk about 50 megawatt to 100 megawatt data centers. So tomorrow's session would be very interesting for everyone. Try not to miss that. Thank you once again. Yeah.
Great things, change things. Wherever we are, whatever we're doing. The information that empowers and connects us comes back to our global data centers. Built for a secure, sustainable, and digital world, they make the invisible visible and anything possible. And that's a great thing. Together, we do great things.
Chennai, known as the gateway to South India, is one of the major IT and data center hubs in the country. The Adani Group now plans to build world-class data center infrastructure in the city of Chennai. The Adani Chennai One Data Center is the biggest hyperscale data center in Chennai with a 32 megawatt IT load. It is strategically located in Sipcot IT Park with direct connectivity to the National Highway and other major IT hubs in Chennai. The data center is being built to meet global standards with 7 layers of security, best-in-class power usage effectiveness, redundant fiber connectivity, and green energy. The Adani Chennai One shall be equipped to provide one-stop solution for all telecom and IT infrastructure needs of hyperscale customers, including low-latency network connectivity, high-performance computing, and other value-added services. Through this data center, the Adani Group aspires to contribute to the local economy while continuing a work towards nation building at large and being steadfast on our philosophy of growth with goodness. Founded in Germany over 100 years ago by Anton Piller, the company has a long history in the manufacturing of exceptionally high-quality electrical machines and power quality equipment. Today, as part of the multidisciplined global British engineering group Langley Holdings plc, Piller is a world leader and innovator in a number of power protection technologies, specializing in UPS systems for mission-critical applications, in frequency converters for aircraft ground power, amongst other uses. Piller UPS systems are found in applications where continuous high-quality power is paramount, such as computer data centers, financial institutions, broadcasting, telecommunication networks, airports, healthcare facilities, and continuous process production sites. Nothing protects quite like Piller.
It's amazing what humans have accomplished. Cars that think, machines that learn, healthcare that predicts. The progress of tomorrow has yet to be imagined, but it will rely on data. It will rely on Vertiv. Vertiv ensures data gets where it needs to be uninterrupted. Critical power is always running. Servers perform at optimal temperatures. Infrastructures grow safely and responsibly. Applications run without glitches, and life leaps forward again. Getting there takes vision and agility. Our leading experts think beyond infrastructure, connecting the dots to create integrated, intelligent ecosystems, to create a future that takes innovation to the next level. And when business needs shift, we work closely with our customers every step of the way. Together, we ensure they are ready before they ever need to be. Vertiv provides continuity in our digital world, so we remain unbound, liberated, free to create the next big thing. Vertiv, architects of continuity.
Great things change things. Wherever we are, whatever we're doing. The information that empowers and connects us comes back to our global data centers. Built for a secure, sustainable, and digital world, they make the invisible visible and anything possible. And that's the great thing. Together, we do great things.